Hello and welcome to another session on Spring Security. This is the third session on the Spring Security series, and in this session I'm going to show you how you can implement Spring Security to do a database-based authentication, which is actually a real-life production scenario. But before I go there, please make sure that if you have not seen the part 1 and the part 2 of this series, the links are there on top, and please go there and watch part 1 and part 2 of the series so that you understand the basics of Spring Security. Now let us come back to this. In this video, I'm going to show you a demo of an actual application where we are doing a database-based authentication using Spring Security. Now this is for whom? This is for anybody who is trying to develop an enterprise-grade application and wants to implement their security using Spring Security, because it is always advisable that we should use Spring Security for an enterprise grade application, because Spring Security has already many really soundproof built-in security features. Now, before I start with the demo, let me tell you that towards the end of the demo, I'm also going to show you internals of Spring Security, and I'm sure that if you watch along with me till the end of the video, you will also be able to understand the internal workings of Spring Security, and then you will be able to explore it yourself. So let us start with the demo, and this is the project which you can see here, and this project is in my GitHub repo, and the link to my GitHub repo is there in the description. And please clone the repo, please clone this specific branch of the repo and then build and run the project. And all steps are detailed in the README here. And please do remember that the branch of the project is this: springboot security using JDBC MySQL-1. So what I'm going to show you here is, as mentioned, how we can implement authentication using Spring Security and against a MySQL user database. So for this to actually run, you need a MySQL database running in your system that can be either locally installed, or what I have done here is I have used Docker to actually run MySQL database in my local system. So that's the easiest way. So if you have Docker daemon running, Docker desktop running in your system, then all the steps are mentioned here, which you can use to actually create a MySQL database. So coming back to the project, let us first start with the pom.xml, which will show you what all we need in this project. Of course, the Spring Boot starter web, and then the Lombok is for all those getters, setters, and constructors, and then the Spring Boot starter security, and the Spring Boot starter data JDBC, which is internally referred by the starter securities JDBC classes, and then the MySQL driver. So these are all the these are all the dependencies that we need. Now let us go and see the security config, because that's the place where we implement security for a Spring Boot application. So here it is very simple. We have declared the data source. Of course, the data source can also be declared in application YAML. And of course, the password can be encrypted using Ansible or using JSIFT encryption. And I have a separate video on that. You can refer to that. But for simplicity here, the password is not encrypted. So here we have created the data source, and this is pointing to a MySQL which is running in my local Docker instance. Now also here, if you see the security filter chain, and if you go to my previous 2 videos, you will understand what security filter chain means. What I've done here is all the endpoints need authentication. So that is the mandate from the security filter chain defined here. And then the important thing for this video, for this JDBC authentication, is I have created a bin of type JDBC user details manager, which is an internal class of Spring Security, which encapsulates all the CRUD operation on the user database. So towards the end of the demo, I will also show you details of JDBC user details manager bin and why it behaves like that. So, but before that, let us run the project following the README, and I will also quickly walk you through the README. What I have done here is I have created a Docker instance, so basically a Docker container for MySQL, and you can actually run MySQL in any way. And then I have created a database named test users, and then these are the two tables which Spring Security needs, like users and authorities. And I have populated a sample data in the users table and the authorities table. The sample data contains the user ID and the password. Note that the password has been hashed using bigcrypt hashing, which is the default hashing algorithm. And if you wonder how I have generated this hash code, then I have also shared with you here an independent class which you can use to create the bcrypt encoded hash for the password, and then you can use that hash here. And along with that, so basically you need to prepend that hash with this bcrypt and then the hash to get the actual password, because what will happen is when Spring Security will try to authenticate a plain text password, it will also hash that provided plain text password, and then it will try to match with the hash which is stored in the database. So that is why it is important that we stored the hash of the password and not the plain text password. But again, there are a lot of variations to this, and I will create a separate video on this hashing. For the time being, for the purpose of simplicity and for this video, please refer that you can use this bcrypt hashing like the way I have just now described. So now you have created, assuming you have created the users and the authorities table, and also you have populated the users and authorities table, go ahead and do a clean package and then start the application. So I have already done that beforehand just to save some time from your side. So I've already compiled, created the package and started the Java application, and I have already created the database. So as you can see, Docker is running for me here, and I have already created the database tables. Everything have been created here. So if I do a select star from users, you will see that I have already created these tables. Now these two table, users and authorities, again are mandated by Spring Security. So the query which Spring Security will do internally to know whether the user exists or not and the password is correct is it will query this users table. So now with this Spring Boot application up and running, let us first try to invoke the endpoint without giving any header field. So of course then it will not be able to respond. It will throw an HTTP 401 or 403, and now we will use this authorization basic header. And if you remember from my previous videos that this authorization basic header contains, this part basically contains a base64 encoded user ID colon password. So in this case, my user ID, as you can see, is test and the password is this. So actually the provided password is plain text. So that is why I have given another separate utility here, create credentials, where this user ID and the password have been joined using colon and then base64 encoded. So if you run this, then you will get the string which you need to pass here, because please try to understand this thing that when I am hitting the endpoint, when I am invoking the endpoint, I am not passing the bcrypt hashed password. I'm passing the plain user ID, the plain password, but it's base64 encoded. And this base64 encoding of the user ID and the password is nothing of Spring Boot security. It is a mandate of HTTP basic header. So whenever whenever you will pass any HTTP basic header, you need to pass it in this way. Now when Spring Boot Spring Security's internal filter will actually intercept this request, and then it will know from the header that it is HTTP basic header, then it will decode this. So from base64 encoding, it will decode this, and then it will get the plain text version of user ID and password. And then Spring Securities will also step in internally, and then it will convert the password into it will basically then hash the plain text password into bcrypt version of hash, and then it will compare with that hashed password with the one which is stored in the database, which means this one. And only if this to match, then only it will let you in. So that is exactly what happens when I provide this kind of basic header. And then you will see that it then lets me to call the endpoint. So then it actually returns a valid result from the endpoint. So again, I will quickly summarize what happens is I'm passing here basically user ID and password in plain text but base64 encoded, which is basically a HTTP basic standard and has got nothing to do with Spring Boot or Spring Security. So Spring Security's filter knows it, and one of the filters intercepts it, and it retrieves the user ID and the password from that header, both in plain text, and then it actually does a hashing, bcrypt hashing of the password, and then compares the user ID and the bcrypt hash password with the one stored in this specific table to find out whether the credentials are correct. If correct, then it actually lets you call the endpoint. So now, if you want to know a little bit more detail of how this actually happens under the hood, then let us go inside the JDBC user details manager, because this is doing the magic internally. Load user by username. So this is the method which executes the query, and you can see here the name of the query, username query, select username password enabled from users where username equal to this, and then it actually retrieves the username password locally, and then there is another layer which compares the hashed password. So this method is executed, and then it retrieves the username and the hashed password from the database, and then there is another utility internally within Spring Security which compares the hashed password. So that is how it works. And another important thing to understand here is this version of user authentication using a database and using Spring Security has a fundamental restriction, or as a fundamental requirement or prerequisite, you can say, and that is the fact that it actually expects this users and authorities table. So with that said, I would like to put an end to this demo. I hope that you have been able to actually get the crux of it, and you can actually use it in production. You can download the code and use it as is in production. You can generate the bcrypt hash of your password and then populate your database, create your database separately. And finally, if you think that I have added value, go ahead and share this with your friends, and also subscribe to my channel for other interesting videos, which is going to also motivate me. Thank you for your time, and bye-bye.